All right, guys. So now I think everything's fine. So let's try and let's try and start solving doubts here. Okay. So sorry for the audio thing now. Uh, just give me a second. Okay, let's start with this. Okay, so now Mugda had this question. So what the agenda of this session is? We'll have the session for like a couple of probably 1 hour, 1.5 hour. Okay, I'll try to solve maximum doubts as you can, as I can, as you can post, you may post. Okay, so here the question goes like this, and so since for the reference I did not have any lot of doubts, so I thought I'll start with Facebook doubts. So the first doubt here that I saw, okay, which wasn't solved like very diligently, if you see like the huge methods used. Okay, a very simple question actually. There are three boys ABC. Okay, they are running in, two of them are running in the same direction. So let's say if I have sorry, let's say if I have A, B and C, they're running, two of them are running in the same direction and one is running in the opposite direction, and the speed ratio is 5:1:1. All right, now the speed ratio 5:1:1, this is the same, this is opposite. The question is, A, whenever it meets B or C, because A is the fastest, it'll meet B and C more frequently, he will give them a card. Okay, so he gives total 33 cards. So you have to find out what is the difference between cards received by B and C. Now this all depends on the number of points where they meet. Now 5 and 1, if you notice, they meet at 4 points because they're running in the same direction, and opposite direction they'll meet at 6 points. So A, when he finishes 5 rounds, B will finish 1 and C will finish 1. In this process of 5 rounds, A will give B 4 cards and A will give C 6 cards. Simple as that. Okay, to start with. So obviously in 5 rounds gives 4 and 6. In the next 5 rounds they'll give 8 and 12. In the next 5 rounds they'll give 12 and 18. Okay, in the next 5 rounds, if he gives again, it will be a number exceeding 33, because here we reached 30 already. Okay, so 30 times they have met, three of them. Okay, like two of them or maybe all three of them, they have met 30 instances by far. They have met on 30 at 30 instances. Okay, but we need 33. So now what happens is, the one simple concept: when you two of them running in the same direction and the opposite direction, the opposite guys, they meet faster than the same guys. Okay, and they meet alternately actually. So the meeting would be like this: the first meeting will be with C, then it will be with B and C, then it'll be C again, then it'll be B, then it'll be C, something like that. Okay, so it goes alternate basically. So if you can actually trace it down, if you go back to my notes of circular tracks, you'll understand. Okay, so now he'll meet C first, so he'll give 19. Okay, and then meet B 13, and then C finally 20, and that's 33 cards, 20 and 13. So the difference of the cards is 7, and that's the answer, option B, 7. All right, let's look at another doubt if you have. All right, I've created the event right there, so you can just go into it and you can find things. Okay, yeah, I think that the audio is proper. What do you think, guys? Give me a feedback quickly. Anyway, so the point is, okay, Jainam, I cannot understand that question in particular. There's a point dimensional square. I've got that question, Kushal. I'll just get back to it. Let's just finish the basic doubts. Okay, so again, coming back to this, I think the remaining doubts have been either answered to. Like, for example, this was like, I answered this as this one, Hamza's question. Okay, 1.2 and 8, you can get the answer. Or you can also refer to the solution I've posted. All right, so let's go ahead talking about a very, very crucial problem here, which is the birthday problem. Okay, puzzle of the week, birthday problem. So the point here is, how is it possible to have two people, okay, on the same birthday? How many minimum people required? The answer there is 20 people. Okay, so if you enter as a 20th person, you will definitely have one of them having the same birthday as yours. Now, how do you do this? I mean, I understand it doesn't look demographically, it doesn't look possible since there are 365 days. Okay, calendar wise not possible, but mathematically it's quite possible, because that's what the beauty of probability is. Okay, let's say the first person can choose any of the 365 days, okay, as his birthday. The next person cannot have his date as the same date as the previous guy, so 364 options possible, and then you have 363 for the third guy. Now if you keep doing this for 20 times, you'll get probability of two people not having the same birthday. Okay, now if you do this 20 times, the answer you'll arrive at is 0.0017. Okay, so probability that you'll have the same birthday, two of them, at least one, is basically 1 minus none. Okay, 1 minus naught, which is 1 minus this answer, which comes out to 0.9998, so approximately 100%. So 99.98% you have a chance that you'll have the same birthday if you're a 20th person. Okay, That's how it's done. We'll be posting the solution to out there. Anyway, going back to your uh, Google doubts. I mean, sorry, YouTube doubts. Okay, yeah. So 20 is the answer. All right. So I think these two were the main questions of the group, which had to be addressed to, and it's fine, successfully done. All right. Let's go ahead. So yeah, the officer that runs shot with a speed of 60 meter per minute. The dog runs to the thief and comes back to the police and show him. Yeah. Yeah. There's a very simple concept actually. Now, when it doesn't really matter the speed here, because the idea is, let's say there's a train here, or any march of officers or whatever, march of soldiers or whatever. Okay, and there's, let's say, a dog here, or any bike here, or whatever, doesn't matter. Okay, very frequent question in exams like cat and zat. If this goes till the front and comes back to find the back here, okay, which means obviously both are advancing, so train will move forward. So by the time this reaches the front, train might have moved forward. Let's say the back here, this distance traveled is always 1 by root 2 times the length of the train. All right, so I think this can be taken care of by a simple way of doing it. There's a quadratic way of doing it. Okay, I'll teach that to you in the class. Okay, there's a quadratic equation way of doing it, but the ultimate answer that you'll get with the quadratic equation is 1 plus root 2 into the length of the train. Okay, anyway, coming back, so x is multiplication. Okay, x is multiplication. Where is x? Okay, fine. The root of 6x square plus 4 are equal in sign but opposite, equal magnitude, opposite in sign, and lies between. Okay, fine. I'll come to that in a while. Okay, the officer has a dog. I think that's done. Okay, the remainder when 30 plus 31. What is dot dot? I don't understand. All right, no problem. The remainder when 3 raised to 0 plus 3 raised to 1 is divided by 13 is. Okay, now dividing by 13, you will have a trend obviously, because 13 is going to be cube. So if you notice, 3 cube by 13, okay, will give a remainder of 1, because 27 by 13. Okay, 3 square by 13, okay, will leave a remainder of 9, and 3 raised to 1 by 13 will leave a remainder of 3. So precisely speaking, the addition of these three remainders actually come to 13. Okay, which means, so 3 power 0 plus 3 power 1 plus 3 power 2, whatever you have, to 3 power 3. In fact, if you go ahead, 3 power 4 is actually, this number is actually 3 power 3 into 3 divided by 13, which this is giving a remainder of 1 anyway. So this will give a remainder of 3. So it belongs to this family. Okay, basically. Okay, so it goes on like that, and it goes till, you have said it goes till, which number does it go till? It goes till 200. So I'll write 200. So it goes till 3 raised to 200. Now 3 power 200 is of the form 3 raised to 2, because it leaves the remainder of 2. So precisely all these will be cancelled. Okay, till 198 will be cancelled. You left with 199, which is of the form 1. Okay, and 200 is of the form 2. Okay, and 3 raised to 0 is of the form 3. Okay, so you'll be basically left with 3 raised to 0, 3 raised to 199, and 3 raised to 200. This is the form 2, this is the form 1, this is the form 3. Okay, so this will give a remainder of 1, this will give a remainder of 9, this will give a remainder of 3, which means the addition is again 13, so 0. That's the answer. The ultimate answer here is 0. Okay, coming back. So what's up? I think you've got this. If you haven't, I'll just share it very quickly with you guys. So I'll just pin it here. Okay. So by the way, also start writing mocks regularly, so that we can actually have a mock discussion session right here in the same manner. Okay. All right. So okay. All right. Remainder when, okay, that's done. N is equal to 2 by 1 into 3 by 4x. 3 by 4 by 3. Okay, 2 by 1 into 4 by 3 into something. Then n must lie between. This is not a big deal, like, actually, Jainam, because you can take a smaller value and then find out. Okay, we can actually get the answer. So it's something like 2 by 1. I think it's into 4 by 3. So it's like 3 and 4, and then you'll have 5 and 6. Okay, and then you have this till 400 by 399. Okay, so let's say I take only this part. Let's try and understand, try and find the answer here itself. So this cancels 2, and this is like around 1 point something, because it's like 16 upon 5, sorry, 3.2. Okay, if I multiply the next 7 by 6 here, okay, so you'll further get further get expanded because it is a number more than one. So every time you're finding a number more than one, which means if you had three terms, the answer was 3.2. If you have four terms, the answer will be 4 point something. Okay, we can just check here. The 32 into 7 by 6. Okay, so it'll precisely be like around, you can use the calci here, 16 7 by 3. Okay, you'll get an answer which is more than 4. So I think 400 will be more than 400. Okay, you can generalize it this way as well. All right, so any other thing? Okay, still waiting for you. uh all right. Okay, so let's talk further. So let's see if we can get some more doubts here, and then we can talk about it. All right, so you also one more thing, guys, keep posting your doubts in this page. Okay, like here. Okay, cat 2015 numbers, please keep pouring on your all your doubts. Okay, anyway, so coming back to the YouTube. Hardik, hi Hardik, how are you? Welcome. If total time taken by x to reach destination is 3 hours more than y, what is the speed ratio x to y? X, okay, there. 7 a.m. Mr. X started from A towards B, and then y started from B towards A at 9. They cross each other, continue the respective journey. If it took x 3 hours more to reach the destination than y, what is the speed ratio of x to y? Okay, you can actually solve this using options. If you can probably give me the options as well, I'll explain you how to solve this with the options as well. But yeah, there is a way out too. Okay, we'll talk about that. Uh, I'm still wanting more people to join in so that they can get the maximum benefit of the same. Anyway, so we were also supposed to discuss one of the sessions, one of the topics here. Okay, on the YouTube I got a lot of comments saying that please share something about something about Chinese remainder. I did that. Something about remainders, I did that. And then something about base. So I gave you a lecture on base too. Okay, base is very simple. Okay, I'll just repeat that one more time. So if you want to convert it to, let's say, from one base to the other, let's say I have 1 2 4 5. Okay, in the base 8, I want to convert it to decimal, like basically base 10. Okay, now base 10 will always act in an intermediate base. Okay, you have to convert, let's say I want to convert this to base 7, you have to first convert it to base 10 and then convert to 7. All right, so how do you convert to base 10 here? First of all, now 8, what do you mean by base 8? Base 8 means there are 8 digits, so cycles are of 8. So 1 means you have crossed 3 cycles of 8. 2 is like cross 2 cycles of 8 twice, and one cycle of 8 you've crossed 4 times, and then 5 more to it. Okay, you can add all of this thing, and that will be the answer here in base 10, and then you can convert that answer to base 7 by a simple process. However, there are some interconversions possible. For example, if I have something like this, okay, in base 2, and I want to convert this to base, let's say, 4 for starters. Okay, now since 2 is a power of 4, okay, I mean, sorry, 4 is a power of 2, sorry for that. Okay, you can actually, which power is it? Second power, like 2 raised to 2 is 4, right? So you can club two digits at a time. Okay, very easy way of doing that. Okay, you can club 2 at a time, 2 at a time, 2 at a time. Here you don't have 2, so you can make 2 at a time like this. So 1 0. Now what is 1 0 in binary? 1 0 is 2. Then 1 1 is 3. 1 0 again is 2, and 0 1 is 1. This will become this number in base 4. Okay, now let's say this one, I'll convert the same thing to base 8. Okay, so now I'll club 3 at a time. So these 3 will go 1 1 0, and then these 3 1 0 1, and then these 3 again. I don't have anything here, so I'll add a 0 0 0 1. Okay, 1 1 0 is basically 4 plus 2 6. 1 0 1 is 4 plus 1 5, and 0 0 1 is 1 5 6. Okay, this will be this number in base 8. You can do the same thing for any base when it comes to power. So you can do the same thing for 3 to 9. Not an issue at all. Okay, so that's how base conversion functions. Okay, and keep in mind, when you have remainders and bases, it's going to be the easiest. Keep one thing in mind. If I ask you, let's say for example 457 in base n, when divided by some number, let's say 2n or whatever, 3n or whatever, okay, or 7n or whatever, let's say I give 2n. Okay, you must know that this n already has a power, a cycle here. So basically it's going to be 4 into n square plus 5 into n plus 7 over 2n. I'm going to find the remainder here. Okay, now I know it's 2n, right? So 2n and 4n square can be cancelled because 2 is with 4 and n is with n square. So this remainder will be 0. This remainder would be, still you have to find what is the remainder. N can cancel, and 5 and 2 gives you a remainder of 1. 1 into n will be the compensation ultimately, and plus 7. So precisely the remainder in this case is n plus 7. Right, if you want to just generalize it, so it can be 3n, 5n, 4n, whatever n, doesn't matter. Okay, just keep that in mind. This is how we'll do it in many bases. Okay, all right, coming back. So okay, so by far Okay, now I have some doubts. That's a good thing. All right, n minus 10 is divisible by 34, n is a positive integer, then the greatest integer necessary to divide n plus 24 and n plus 58 is. Okay, now in such questions, Anurag, when you have n, okay, you got to focus on something very special. That focus is divisible by 34 when n is a positive integer. Now it's divisible by 34. Now what is the least number that can divide 34? 0, obviously, but 34 itself also divides 34. So in that case, n becomes 44. Okay, which will be the greatest integer that necessarily divides n plus 24 and n plus 58. You have in that case n plus 24 is going to be n, so sorry, n plus 24 is going to be, okay, and the other one was I'll have to do something more switching. Okay, n plus 58, n plus 24, n plus 58. So n plus 24, n plus 58. So each case you'll have 44, 44. 44 plus 24 is how much? 68, and 44 plus 58 is 102. Okay, you multiply these two, and whatever can divide these two is precisely the answer. So 68 is 17 and 4, 102 is 2 and 17 and 3. I think 17 is in both cases, so 17 square it can divide precisely, or something like that. Okay, look at the options and you can find the answer. All right, moving forward. So we have something like sweetness of various item whose sweetness is taken as 1. Sucrose is 1, or lactose 16, whatever. What is the minimum amount of sucrose added to 1 gram saccharine to make a mixture of at least 100 times sweeter than glucose? Now, glucose is 74, 100 times sweeter will be 74 into 100 precisely. Okay, so saccharine is 675. Okay, 1 gram of saccharine. Okay, is it 1 gram of glucose? Check that. I mean, doesn't really matter as such, but no problem. All right, so you have saccharine 675, and you have to add sucrose to it. Sucrose is 1. Okay, fine. So you got to basically have something like this. 675 and 1 gives you 75. Use allegation and you can precisely find the answer in this case. Okay. All right. Because addition is always about mixing. So it's mixture is all about allegation, because I did 75 because 0.74. Okay. 0.74. So take it 74 instead of 75. Okay. All right. Anurag says again, 677 is exactly 5 digits when converted to base n from the decimal. What is the minimum value of n? Now, okay, let's talk about that too. Now, how do you decide the number of digits in a base? Okay, is a question. How do you decide the number of digits? Now, how do you say that this will have these many digits, that will have these many digits, whatever? Okay, in any base for that matter. Now, for example, 10. Let's say I want to convert 10 to base 2. If I convert 10 to base 2, okay, I know that 10 is, I mean, you can directly say 10 is basically 8 plus 4, 8 plus 2. So it is 8 present, 4 absent, 2 present, 1 absent. Yeah. So it's 4 digits. All right. So 10 in base 2 has 4 digits. Okay. Why? Simple reason. It is higher than 2 cube. In base 10, what has 3 digits? Whatever numbers are higher than 10 square. Okay. So if the number in concern is 677, okay, it must be higher than some raised to 4. Okay, because you want a 5 digit number out of 677. 677 must be a 5 digit number in the base. Okay, so which means that base's fourth power must be more than 677. Okay, sorry, the reverse. 677 must be more than the base's fourth power. Okay, so it is more than base 2's fourth power, base 3's fourth power, base 4 fourth power, base 5's fourth power, sorry. Yeah, but it's not more than base 6's fourth power, because base 6's fourth power is 1296. Okay, but base 5's fourth power is 625. Yeah, so that's why 677 when expressed in base 5, okay, will have 5 digits. Okay, so the exact value is 5. Okay, the base value is 5. All right. Okay, let's go ahead. X square. Okay, this says 24.375 base 10 is what in base 2. Okay, so now basically what you do in base 2 is you want to convert a decimal to base 2, for example. So let's say you have AB dot CDE. You want to convert this to base 2. Okay, this is in base 10, let's say. Okay, so the ideal way out is you probably divide it by keep dividing by 2 and then formulate it and then write it the other way. Out here as well, you got to divide by the reverse powers of 2. Okay, that way, because ultimately they'll be multiplied and then, you'll get the equivalent value in that case. Okay, in the decimal form. All right, the next says x square minus 3y square is 1736. How many integral solutions exist for the given equation? Okay, like I'll just go to that because that's a special equation question. Actually not, but we can still, it's subtraction of squares wherein one square is tripled and the other square is just the square. Okay, not a big deal. We can tackle that too. All right, so any more doubts, guys? So I think the base number of digits point is clear. Okay. So infinite sum, this is an arithmetic or geometric progression question. We will talk about that in the session. Okay, infinite sum question, 1 plus 2 by 3 plus, if you notice the numerator here, okay, in this question the numerator goes in arithmetic progression and the denominator goes in geometric progression. The very simple way of doing it, I'll talk about it in the class someday. Yeah, there is a shortcut direct answer you can get in such questions. I mean, you have one thing to remember and that's enough. Anyway, so moving on. All right, so I think, okay, so this is fine, I'm sure. So any base you want to do it, okay, you can do it this way. You can divide those numbers by corresponding things and you can get the answers. Anyway, coming back to the number of digits of the bases. So that's why, let's say for example 1000 in base 2, you just have to find out which power of 2000 is just ahead of. So if you notice, it is ahead of 5 and 2. Okay, 5 and 2 is what? 2 power 9. So 1000 will have 10 digits. So it's a 10 digit number in base 2. 1000 you want in base 3. Which power of 3000 is just ahead of? Now 3's power, if you notice, 3 raised to 6 is 729 because it's 9 cube, which is 3 square the whole cube. Okay. So 1000 will have 7 digits here. Okay. And 1000 in a base 4. Okay. Which power of 4 is ahead of 1000? I mean behind 1000. So fourth power is 256 and the next power is 1024. So definitely it's fourth power, which means it'll have 5 digits in base 4. Okay, same goes for base 5, 625 and it'll have 5 digits. Okay, and so on. You can find out for the rest of the bases. Okay, 1000 in base 10, it is it is exactly the third power. That's why 1000 has 4 digits in base 10. All right, let's move on. Any other questions that you have? Please, I told you guys, next time when we have a doubt clearing, please keep your doubts ready. Okay, so that I can also solve them really fast and get them sorted. Okay, so okay, let's go ahead. All right, so let's talk about something else then, in that case, if you don't have any more doubts. All right, so let's talk about, let's say you want to talk about something like yeah, I was talking YouTube. On YouTube I've got a lot of queries, like, you want functions to be solved, you want logarithms to be solved. Now I'll just give you a brief on logarithms. Now what logarithm is basically an output. Okay, it's an output. It's an output which is precisely like, generated because of the index. Okay, let's talk, it's basically the index. Okay, logarithm is nothing but the index. Okay, so I'll tell you how this works exactly. I'm so sorry, there's celebration going on behind me, so bear with the noise. Okay, so 2 power 3 is 8. Yeah, this is sweet lady, sweet lady voice going on. All right, so 2 cube is 8, right? So when I want to write this in a log, I'll write log of 8 in the base 2 is 3, which means if I find out, what is the logarithm, what is the index of 2, what is the index of 2 when the input is 8, I get the index of 2 is 3. Okay, that's how we deal with logarithm. Logarithm is basically an output. It gives you an index, nothing but an index. Okay, so let's say for example, if I have something like this, log to the base 10 random number, I'll take 25. Now I know that in base 10, which means using 10, I cannot reach 25. You have to strictly use the number here. Okay, you can't use the number like this. Okay, that's not log. Logarithm is always the index. Okay, so I know 10 power 1 is 10, I know 10 power 2 is 100, so 25 is between it, 100 and 10. Yeah, that's why the answer will be 1 point something. Keep that in mind always. Okay, so it'll come in a little handy for you. I mean, you know that 25, I mean, compared to 100 is too far away, which means it'll be near, near 1.1s or 1.2s and stuff. Okay, that's how this functions. Simple as that. Helpful in finding the number of digits too. So for example, if I ask you how many digits does 1000 have in base 2, Okay, and that's how I calculate the digits question. Okay, very simple again. How do you go about this? You say that it is between 2 power 9, which is 512, and 2 power 10, which is 1024, and 1000 is between these two numbers, 512 and 1024. So that's why the answer will come out as 9 point something. Okay, now whenever a logarithm, now this portion is very important logarithm, this is called the mantissa. Okay, and this is called the exponent. No, not the exponent actually. Okay, it is called, it is called the, I forgot the name actually, mantissa, and I think it's called the exponent. Anyway, that doesn't really matter, but the main focus is on the mantissa. Okay, now mantissa is 9. Now if the mantissa is 9, which means 1000 will have 10 digits. If the mantissa is 1, if you notice here, mantissa was 1, that's why I got 25, which is 2-digit number. Okay, so for all 2-digit numbers it will be 1 point something. For all 10-digit numbers it will be 9 point something, something like that. Okay, yeah, so let's go ahead. Again, coming back to you guys, 28 number of coprimes less than n. Yeah, I'll talk about that. Actually, I'm making a video, okay, on the same. How do you find coprimes in the best, most effective manner? B is twice as efficient as A and can do a piece of work. A can do a piece of 15 days. Arey yaar. B is twice as efficient as A and A can do a piece of work in 15 days. If A can do the piece of work in 15 days, B can do the same work in 7.5 days because B is twice as efficient. So if A is 15, B is going to be 7.5. You can take the LCM as 15 and then go for it, and then you know the method now. Okay, so let's go ahead. Number successfully divided, successfully नहीं है वो, successively है, no problem. Successively divided by 567 leaves a remainder of 251. What is the remainder when the same number is divided by 210? Now successive division is something that is very important. 567 leaves 251, right? What do you mean by this? 567 leaves a remainder of 2, 5 and 1. So these are the quotients here, and these are the remainders respectively. Okay, now what this means is, okay, what, yeah, characteristics. Thank you very much for that. Thank you very much. Okay, no problem. Thank you. Okay, so when you first divide the number by 5, okay, you get a remainder of 2. You then divide by 6, you get a remainder of 5, and then you divide by 7, you get a remainder of 1. If you want to find this number, all you do is go zigzag. Okay, whenever you go top, multiply, whenever you come bottom, add. Go top, multiply, bottom, add. Okay, so let's start. 1 into 6 is 6, 6 into 5 is 11, 5 into 5 is 55, plus 2 57. Now let's check. I'll just show you how this functions exactly. Okay, just to retrace the method. Okay, so now when I divide this by 5 first, I'll keep the track of the quotient. Successive division means you keep the track of the quotient and the remainder both, not just the remainder. Okay, because you are also diminishing the number. So I'll show you how this works. The quotient here is 11, the remainder here is 2. Okay, then I'll take the quotient again, divide by 6, because the next quotient is supposed to be 6. So quotient here is quotient here I get is 1, remainder I get is 5, and then I reuse the quotient, okay, the diminished one, and divide by 7. The quotient here is 0 and the remainder here is 1, which means quotient 0 means the division is ended. You can't successfully divide the number again. All right, so I think that's pretty sorted. So 57, that's how, like, you don't do the entire process, just go like multiply, add, because ultimately it's the remainder here which is going to be multiplied by the quotient here, okay, added to the remainder here, and then multiplied by the quotient here, and then added to the remainder here. That's how this exact functions exactly. Okay, and that's why it can be done easily. So you found the number 57, and the question now is 210. Definitely would give the answer now. Yeah, Sachin, thank you for that. It's called characteristics. Yeah, guys. Okay, it's called characteristics. So the front, I mean, I'm too exhausted with this entire Ganpati thing. So sorry, but not hurting anyone's sentiment here, but it's too noisy out here. Anyway, so the front portion is called the mantissa, the later is called characteristics. I'm still using exponent. Anyway, so let's go ahead. If all the pipes are kept open, where is the pipe starting? Okay, a tank is connected 8 pipes, some inlet, some rest are outlet. Inlet can fill in 8 hours. Empty outlet can empty in 6 hours. Okay, fine. All the pipes are kept open. Tank will take exactly 6 hours for the tank to empty. How many of these pipes are emptying pipes? Okay, there are 8 pipes. I'll just take a gist to the question. 8 pipes. Inlet is 8 and outlet is 6. Okay, fine. So the inlet is 8 and the outlet is 6. I'll just take 2 because at least I need one inlet, one outlet. Okay, I'll just take 2 right now. Okay, what is the LCM here? It comes to 24. This is going to be 3. This is going to be 4. So the outlet is emptying in 4, and inlet is filling 3 every hour. Okay, so net is going to be -1 in 1 hour. In 1 hour, -1. Okay, so precisely -1 in 1 hour will reduce 24 in 24 hours. Okay, but you don't want 24 hours. The work entirely gets done in 6 hours. Okay, so 6 hours is empty. All right, so in 6 hours is empty basically, which means you must have a negative of 4. Okay, one inlet and one outlet can give you a negative of 1. You need a negative of 4, which means there are the same number of inlets and outlets. Okay, so 3 minus 4, one more time, one more time will give you 4, and that can empty the tank in 6 hours. I think that's good enough. All right, so anyone else posting anything? Okay. All right, guys, I'm still waiting for it. All right, so I'm just reading your WhatsApp doubts now. Yeah, you can come there directly. Okay, so yeah, one of the doubts was on WhatsApp. Das Kadam was a group, and there was a doubt, which was, yeah, it was a base doubt actually, and the other doubt was there are 6 locks exactly with one key for each lock. Okay, I'll read the question. There are 6 locks and one key for each lock. So 6 locks, and every lock has a key. What are the minimum unsuccessful attempts required? A very simple question. I don't know why this became a doubt, but still a very easy one. So obviously, let's start with the first key. Let's just try to do this realistically. Now, in CAT, remember this. Always try to solve problems a little realistically. Think about it like the actual situation. What do you do? Okay. So the first key. What do? You try 6 locks. You obviously have one match, which means you have 5 non-matches. So now we know one lock that is open and 5 locks that are closed. Again, you take the next key. You'll have 4 non-matches, 3 non-matches, and 2 non-match, and 1 non-match, and 15 is the answer. All right. I think that pretty much solves it. Okay. The exponent of 2 in 100 12 and 100 factorial. Okay, fine. You want to find the exponent of 12 and 100 factorial. So 12 is basically what? 12 is 2 square 3. Okay. I know 100 fact has, you can find with successive division. 100 fact will have 97 2s and it'll have 48 3s. But I don't want 2s. I want 2 squares. So I'll have to divide this by 2. If I divide this by 2, I get 48 2 squares. I hope you're getting this, because when I have 97 2s like this, 98 times, 97 times, doesn't matter actually. It matters, sorry. And you merge 2 of them, okay? You will get 48 pairs of these. Okay, 48 pairs of these will make a 2 square, and there are 48 3s, which means I have 2 square 48 times and 3 48 times, which means I have their multiplication 48 times. Okay, 2 square into 3. So the exponent value in 100 fact is 48. How do you get -4 in time and work? 24 divided by 6. It takes 6 hours, right? So every hour it goes -4. All right. Still you're coming. All right. So let's go ahead. Any more questions? If not, let's just solve some other doubts as well. Like for example, one of the doubts that I got, a nice one, which was like this: 2 to the power 100 divided by 91, 3 to the power 90 divided by 91. I just want you guys to try this out, okay? In your free time or wherever. If you can try now, go ahead, try now, and get me the answers. Not so great questions, but they were asked in previous year papers and stuff. All right, so let's move on. Let's just see if you have more doubts here. Next time onwards, please make sure that your doubts are already prepared and ready, and you know, anyway, next time onwards we will be having group doubt solving anyway. But still, when you have a generic one like this, make sure you have a doubts in place. Okay, so coming back, remainder when 3 raised to 256 divided by 13. Okay, 3 raised to 256 divided by 13. Now 13 has co-primes 12, so it'll be 3 raised to 12 will always leave a remainder of 1 with 13. Okay. So you just have to find out 12. How many 12s do you have in 256? 256 is basically 12 into 20 is 240. Okay. And then you have 12 into 21 is 254, 252, sorry, which means you're left with 5 more. So it's basically only turns down to 3 raised to 5, which basically means, so sorry for going a little fast, 3 raised to 12 raised to 21 into 3 raised to 5, right, over 13. This will give a remainder of 1. You're left with 3 raised to 5 by 13. Okay, 3 raised to 5 by 13 can be easily solved because 3 cube, okay, I just told you about 13s. 3 cube into 3 square over 13, this is 1 and this is 9, so 9. All right. Also, I especially took this question for a reason, because now you know 3 and 13 have a very beautiful property that they have a cycle of 3, and the remainders will be either 1, 3, or 9. Okay, so you can just find out whether 256 belongs to a 3 family or not. Which family does it belong to? So it belongs to the raised to 1 kind of family. Okay, 3 raised to 2 kind of family. Sorry, 13. Okay, 13, 11 to 13. Yeah, 13, correct. 252. Sorry, this is 4, and then 1, and then you have 3. Yeah, so the remainder is 3, not 9. Sorry. So it belongs to a family of 1. So it belongs to a family 3 power 1. 3 power 1 by 13 will leave a remainder of 3. I hope that is fine. Let's go ahead. So 91 is 13 sevens. Yeah, you can go ahead and do that. Where was I? F of 1 is 2 by 2x, and f of nx is 1 upon 1 upon f of nx. When n is more than 1, find the approximate value of f51. Okay, Jay, we can solve this question when we take a doubt clearing on functions. Right now, I want those doubts that we already covered in the like the chapters which we've covered in the sessions. So focus on those things. Thankfully, it stopped. Okay, now it started again. All right. All right. So now, shit. It's seriously okay. One particular session that I wanted to conduct. Okay, was especially on induction. Okay, which we'll be talking in the next doubt clearing. Okay, which will be this week. Okay, this week onwards we'll have at least 3 doubt clearings every week. Okay, because now October is kicked in. Okay, three doubt clearings every week. All right, now I'll give you a small idea about how do we function now. Okay, what to do in the last 60 days of CAT. Let's talk about that too. Okay, so when I talk about what to do in the last 60, I've spoken about the preparation and all in the class itself. I'm not talking about that. I'm talking about what we will do here, maybe online or something like that in the next 60 days. Okay, first of all, we'll have workshops. Workshops will start on 3rd, that is this Saturday, 3rd of October. All right, next is I want you to have mocks. Please write the first mock. Okay, because we'll have an online mock discussion on Wednesday or a Thursday evening. I'll tell you the exact day. Obviously, I'll announce it across. Okay, and then we'll have a doubt clearing on Friday, and one more before that will be on Tuesday. That is day after tomorrow. All right, so sounds cool. 3 doubt clearing, and we'll have mock discussions. Okay, mock discussions we'll have 1 per week for now. Okay, and next week onwards we'll have 2 per week. So next week you'll have to write 2 mocks a week anyhow. All right, so please make sure your preparation is around this, kind of 3 doubt clearings. Okay, yeah, this is apart from the Skype doubt clearing that we have. Okay, Skype is different. Skype is only meant for the groups. That will be a private doubt clearing session. This is going to be more like public. Everybody can attend this doubt clearing. All right, that's how this is. And yeah, one more thing, the workshop sessions will also be streamed, as in on our website. Okay, so you can get your hands on them as well. Okay, we will talk about that in detail in the class to you guys. Anyway, so coming back, no more doubts, I think. All right, so we can do that doubt later on, Jay, if you want to. Let's move on to something like let's say, for example, something like non-negative solutions. Please pour in doubts on non-negative solutions after this. Okay, I just want to share a question with you. Okay, try this. A plus B plus C is 40. How many values can A, how many non-negative values ABC assume if they lie between 0 to 20? Okay, so they can't exceed 20 and they can't be below 0. Okay, because anyway it's non-negative, but still you can have sometimes negative constraints too, so it's big deal. I mean, not a problem at all. Okay, let's go ahead. So I think we'll have to then, in that case, I don't have any doubts to discuss. So I think we'll probably shut it down then. No problem. Next time, please get your doubts. I've been telling this to you since morning, since yesterday, in fact. Okay, please get your doubts sorted and get them to me. Should be great. Okay, so that's it for now. I think we'll stop here. I think because of Visarjan, a lot of people are not around. But next time I want a full attendance. Please make sure you do that. Okay. Thank you very much. Hope you have a nice time.